8.4, exponential functions and comparing functions. So last time in class, I guess it's been a while, this is a little late, but we did a first part of 8.4 doing exponential functions, and then today, which is the 21st, I think, I don't know, 21st and 22nd, we'll be comparing functions. So I already posted a video on comparing functions. And I also did one for exponential functions, but for some reason it wasn't working, so I'm just going to make a new one. Alright, so exponential functions. Quick review on how we can do exponent rules, which we did this in 4.1. Anything to the 0 power is 1. 2 to the negative 1. Okay. We never want to have negative exponents, so how we can take care of that is we will do the reciprocal. So we will write it as 1 over 2 to the positive 1. So whenever you do the reciprocal, you change the sign of the exponent. So here that would be 1 over 2. Okay, a little more complicated, 4 to the negative 2. So the same thing, we don't want a negative exponent, so we'll do the reciprocal. We'll do 1 over 4, but we need to change the sign of the exponent. So that'd be 1 over 16. Alright, and then just a quick review on when we have the same bases, the base is 2, and we are multiplying them, what do we do with their exponents? We add them. Okay, so that'd be 2 to the 10. And we don't multiply the bases will stay the same. Alright, if we have a power inside of a power, we multiply the exponents, so 6 to the 15th, or for this one we'd have 3 to the 8. Okay, so that's just a quick review on exponent rules. Okay, and all of this, for this lesson, everything is just a review except for the very end. So whether you did it last year or the year before, depending on where you went to middle school or junior high or went to Vista, you should already know these. But we'll just do a review. Okay, exponential functions. Exponential functions look like this, where A is the initial value and B is the growth or decay factor. So for example, we use this equation oftentimes when we are doing, like for example, when we invest, like when we put a certain amount of money into your bank account, like for example, you put $100 in, and your interest rate would be maybe 1.01 to the x. So every year your money will increase by 1%. Okay, and we'll talk more about interest rate, or not interest, but just rates and the difference between a rate and a factor. Okay, so let's look at these examples. So f of x, so this is function notation, f of x equals 2x. So looking at that, what is a? And you may say, some people say 1, some people say 0. But the thing is, if you put 0 in there and you multiplied it, that whole thing would be 0. And that wouldn't help us at all. So basically what we're doing is, if we don't have a number in front, it would be like 1 times 2 to the x. And then b is our 2. And we'd want to come up with this table. So here you could plug it in your calculator. You could just graph this equation, 2 to the x, and then you could make a table that way. Okay, but either way, you're going to have, this would be 2 to the negative 2. Or you could plug in your calculator, or you can realize using exponent rules that you would want to bring it to the bottom and switch the sign of the exponent, which would give us 1/4. And you can continue going, you'd get 1/2. 1, because 2 to the 0 is 1. And here we would get 2, 4, 8, and 16. right? So sometimes people say, well, why is anything to the 0 power 1? Well, if we kind of look at this table, and we notice that there's a pattern that it's dividing by 2, we have no reason to expect anything else. So if we divide 2 by 2, you get 1. Divide that by 2, you get 1/2. Okay, so in that reasoning, we can say that anything to the 0 is just going to be 1. Okay, so we can come up and graph this. 1/4, 1/2, 1, 2, 4. Okay, and this is exponential growth. It's getting larger and larger as time goes on, or x goes on. Okay, and then the other way is where we have a is 1 but b is 1/2, and you could plug that in and find those things. 1/2 to the -2 is I think it's 4, and then 2, 1, 1/2, 1/4, 1/8, and 1/16. And we could graph that, go here, 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 all the way to there. And this, would this be growth or decay? Right? And I think you probably just say decay, maybe because underneath there it says decay factor. But it's because, well, it's decaying, or it's getting smaller as you go on. Okay? All right, so growth factor is when b is greater than 1, and the decay factor is when b is less than 1. All right, so looking at the next thing, we're talking about, see if you can figure out how they end up giving us the growth rate. So on your homework and on your quizzes and your test, you'll be asked, giving an equation, something like that, you would need to write down what is its initial value, what is its growth or decay rate, and what is your growth or decay factor. Okay, so here we already talked about the factor. This would be the growth factor because it's greater than 1. But how do we go from there to here to get the growth rate? Or get from here to here, or from here to here, or here to here. Okay, so the best way to figure this out is we'll just say, I think obviously you can kind of see this relationship between 1.23 and 23%. So here we can notice that it is the difference between b and 1. So b minus 1. All right, b minus 1. And so the difference between 1.61 and 1 is 64%. Okay, oftentimes if you did it this way, you'd get 1.23 minus 1, which would give you 0.23, but we need to write it as a percentage. So we just basically move the decimal over twice and write it as a percentage. Okay, and then these ones, it's the exact same thing. We want to find the difference between b and 1. But now that it's less than 1, we will use 1 minus b. So, for example, here 1 minus 3/4 gives you 1/4, or 0.25. And then write it as a percentage would be 25%. Okay? Same thing, the difference between 0.39 and 1, that will give you 61%. All right, so pretty simple. Just remember the factor, the growth factor or decay factor, is just a number. It's not a percentage. Okay, it'll just be what is underneath the exponent. Okay, and then the rate is the difference between b and 1. Okay, so let's do some examples. Hopefully that will help. There we go. Okay, so identify the initial value, growth or decay factor, which is not a percentage, and then the growth and decay rate, which is a percentage from 1. Okay, so here initial value, you can just abbreviate these things. Initial value for all of these. Initial value here would be 4. Here would be 5. Okay. Decay or growth factor. With this is our B value. Is that growing or decaying? Is it greater than 1 or less than 1? So since it's less than 1, it would be decay. And that makes sense because if you say, let's just start with x equals 1, you would just basically be multiplying 4 and 0.78, which is like a fraction. So we know that it's going to be less than 4 when x equals 1, and then it will even get more and more smaller as time goes on. Okay, so decay factor is going to be 0.78, and then decay rate is the difference between our decay factor and 1, which will be 22%. Okay, so just again, I'm okay if you just go straight from there, find the difference between this and 1, or you could say, well, we know Mr. Warner showed me that the decay rate is going to be 1 minus b, which is 1 minus 0.78, which is 0.22, and we'll want to write it as a percentage, which is 22%. Okay, so either way, my guess is once you figure this out, you'll just be able to write these things down pretty quick. All right, this other one, is this growth or decay? It's growth because it's greater than 1. Growth factor will be 1.47, and then the growth rate is the difference of b and 1, so that is 47%. All right, I'd love it if you could pause and do 3, 4, 5, and 6. Make sure you're doing it all right. And then unpause and you'll watch me do the rest, okay? All right, so initial value for all of these are just these values. You just want to write them down. Don't just circle them, right? IV 0.6 or something like that for all of those. And then we'd want to see, is this growth or decay? It's greater than 1, so it's growth. The growth factor is going to be 1.19, and the growth rate will be 19%. Okay, 19% growth. Okay, this one, decay factor is 0.36. Decay rate is going to be the difference of 0.36 and 1, which will be 64%. 64% decay. Next one, we have decay again. Decay factor is going to be 0.4, and then decay rate is going to be 60%. Here we have growth. Growth factor is 2, and growth rate is going to be the difference of 2 and 1, which is going to be 1 or 100%. Okay? Okay, and then this is the new stuff that you haven't covered before. And the only thing that's different is that we have these little numbers in our exponents as well. All right, so in that case, we can make it look like we have here before by first making a parenthesis around everything except for the x, and we're going to evaluate it, 1.05 to the fourth, which gives us 1.22, and we still have our x out there. All right, and we can do that, and this is basically the opposite of a power inside of a power, because a power inside of a power, you multiply them, and here instead they're multiplied. We're just going to bring it out, make it be a power inside of a power, and we're just going to evaluate the number, if that makes sense. So here now, this will be our b value. Make sure that this is not our b value. So we'll have growth. Growth factor is going to be 1.22, and the growth rate is going to be 22%. Okay? And none of these for 7 through 12 have initial values, but I feel you probably understand initial values. So the initial value for all of these would be 1. Okay? All right, and so you just want to do the same thing with all of these. We would draw our parentheses, excluding the variable, and then you will just come up with, sorry, excuse that. I'm just going to get mine so I don't have to spend a lot of time. All right, so here they are. Okay, so these ones, you will just plug them into your calculator, 0.68 to the third, that gives you 0.31, okay, and then we would just say, oh, that's decay factor is 0.31, and decay rate is 69%. Okay, this one you'd evaluate for 9, would get 3.11 to the x. This would be our b value, so our growth factor, because it's greater than 1, is 3.11. And then our growth rate is the difference between this and 1, which gives us 2.11, or 211%. Okay. Next one, this is also growth. You can find that it's growth even before you square it, because if you multiply something that's greater than 1 by itself, it's still going to be greater than that. So here we got 1.56 to the x. So our growth factor is 1.56, and the growth rate is going to be 56%. Again, next one, we have 0.097, round that to the 10th place, which would give us 1.0, or 0.10, okay, to the x. And then our would have growth or decay. It would be decay, because it's less than 1. Decay factor would be 0.1. And then decay rate would be 90%. And then the last one would evaluate 0.35 to the 4th. That gives us 0.073, or we'll round to 0.07 to the t. Our decay factor, because it's less than 1, is going to be 0.07, and decay rate is going to be 93%. All right, so it shouldn't be too bad. Although it's probably been a little late if you're watching it now, but for that day we only had to do, let me show you your homework really quick. So if you go to the homework, 13 through 20 is what is due on the 21st and 22nd, and the rest of those 1 through 12 will be due the day after that. Okay? All right, thanks for watching.